We're going to talk about composition of functions in this section. A composition of a function is when you use a function within another function. So notation, you'll see f of g with a small circle of x. So when you read that, you're either going to read f composed with g, or you can read it as f of g of x. So either one of those phrases means you're taking the composition of a function. Uh, Other notation you might see is just f of g. That means you're going to compose f with g. And algebraically, what that means is you're going to plug g of x into f of x everywhere you have a variable, or in this case, we're using x. So you're going to take whatever they give you as the g of x function and plug it into f of x. So first, let's look at how you do compositions when you're given a table. So this first one says evaluate f of g of 3 and g of f of 4. So the first thing you're going to do is you're going to start from the inside and work your way out. So here we've got f of g of 3, and we're going to start with g of 3. So if I look at my table, I'm looking at the table that uses g, and when x is 3, my g of x is 2. So this coordinate, it corresponds to g of 3. So here g of 3 equals 2. So I'm going to plug that in where g of 3 is. So that's f of 2. So I've plugged in the 2 in for g of 3. Now, this tells me to find f of 2. So I move over to my f table, and at 2, I have the coordinate 2, 8. So here, this says that f of 2 equals 8. So my final answer here is going to equal 8. So f of g of 3, or f composed of g of 3, is going to equal 8. So basically work from the inside out. On this next one, g of f of 4, I'm going to find f of 4 first, and that equals 1. So I'm going to plug that in for f of 4. So when I need to find g of 1, I'm looking at the g table. G of 1 equals 3. Now on the next example, we've got a list of compositions, and it's all on one table, but it's the same concept as the previous. I'm working from the inside out. So f of g of 7, g of 7 is going to be right at 3. G of 7 will be 3. And then I go find f of 3 will be at 8. So I map to find the g of 7 first, which is 3, and then find f of 3 on my table, which f of 3 equals 8. So same thing as the other ones. If I've got f of g of 5, g of 5 is going to equal 8, and then f of 8 would equal 9. And your table can get kind of confusing if you continue that. So moving on to C, f of 5 is going to be 0, because this is f of 5. And then I need to go to g of 0, which is going to be 9. G of f of 3, f of 3 will be 8, and then g of 8 will be 4. And then the last one, I have f of 6. So same thing, f of 6 is going to be 2, and then I need to find f of 2, which is going to be 5. So work from the inside out, and you'll get to the answer once you compose the other one within the original function. Now that's dealing with tables. Algebraically, we've got two methods, and they both work. It's just one's easier depending on how the question is asked. This one, we've got given f of x equals x squared minus x, and h of x equals 3x plus 2. We want to evaluate f of h of 1. So just like we did at the tables, I'm going to find the inside first, h of 1, by plugging 1 into my h function. So I'm going to have 3 times 1 plus 2, which is going to give me 3 plus 2 is 5. And then I'm going to plug 5 in here and find f of 5. So now I move over to my f function and plug 5 in for x. So I've got 5 squared minus 5, which will be 25 minus 5, which will give you a final answer of 20. So f of h of 1 is equal to 20. So if it asks you to evaluate at a specific number, you can just begin by plugging the number in and work from there. Method 2 is if it asks for you to give the composition in terms of your variable. So here it wants me to find f of g of x and g of f of x, and then evaluate at specific values. So when this is asked in this way, you're going to work with the functions before you try to plug something in. So if I'm trying to find f of g of x, that means I'm going to take g of x and plug it into my x into f of x. So in this case, I've got x plus 1, and that's going to be squared because I've taken this and plugged it in for x. Now you can leave that as your answer, or if you want to go ahead and FOIL that out, we've got x plus 1 times x plus 1, which will be x squared plus 1x plus 1x plus 1. So you'd have x squared plus 2x plus 1. I am fine if you leave it squared or if you go ahead and square it. Either one of those is acceptable. Now the next one, let's find g of f of x. You're going to do just the opposite. You're going to take f of x and plug it in for your x into g. So that's going to be x squared plus 1. And you can stop there. There's nothing else you can do there. So we've taken f of x and plugged it in for x, and then you have the plus 1. So those are your two composition functions. And now I could ask you at any point, give you any number to plug in, and you can find the answer. So if I want f of g of 4, I'm going to plug it into this function. So I'm going to have 4 squared plus 2 times 4 plus 1. So 16 plus 8 plus 1 will give me 25. So f of g of 4 equals 25. And then if I want to find g of f of 4, you're going to use that equation, the x squared plus 1. So I'm going to have 4 squared plus 1, which is 16 plus 1. So that final answer is 17. So just depending on how it asks you in the beginning, which way it'll be easier, either to just plug the number in first and work from there, or if it wants your answer in terms of x to start with, you work with the functions and then put it in the number. Let's look at this next example. We've got f of x and g of x, and it wants us to find 4 different things. So let's look at A. If it wants f of g of x, that means I'm going to plug in g into f of x. So I'm going to take my g and plug it in for the x in my f of x. So I've got -6, and where the x was, I'm going to put 9x minus 1, and then I have -4. So the whole function is my f of x, and I'm plugging in g of x where the x's are. And then you can simplify. I'm going to distribute that -6, so it'll be a -54x plus 6, and then we've got the -4, which will leave us with -54x plus 2. If we look at B, it wants us to find g of f of x. So we're going to do just the opposite here. I'm going to take f of x and plug it into g everywhere you have an x. So I'm going to have 9, and where the x is, I'm going to have -6x minus 4, and then we've got the -1. So this is your f of x that you plugged in for x. So again, simplify. So I'm going to have -54x minus 36 minus 1. So I'll have -54x minus 37. Okay, the other two, we've got f of x is what C is asking you to find. So don't get too confused in here. Basically, you're plugging your function in itself. So everywhere there's an x, I'm going to plug in the f of x. So I'm going to have -6, and then where my x is, I'm going to have -6x minus 4, and then you've got the -4. So this is, we're plugging in f of x right here into f of x. And then simplify from there. I'm going to have a positive 36x plus 24 minus 4. So I've got 36x plus 20. And then D is asking you to find g of x. So I'm going to plug g of x into itself. So I'm going to have 9 times 9x minus 1, where the x is, minus 1. So I've got 81x minus 9 minus 1, which is going to give me 81x minus 10. So there's a couple different ways that you can be asked to compose functions. Let's look at this last example. We want to find f of g of x and g of f of x, and then again evaluate them at 4. So let's look at f of g of x first. F of g of x, I'm going to have this plugged in for x. So you're going to have 1 over x minus 2x. And then that whole thing is squared, because this was where you had x before. So that's your x squared, and you plugged in g of x. Now, you can leave it like this, or you can go ahead and FOIL it out, but it's kind of a mess to FOIL. So I'm perfectly fine with you leaving it in that form. If you want to look at my notes, I showed it FOILed out, but it's fine to leave it like this in your homework. So let's look at the next one, the g of f of x. This is just the opposite. I'm going to take f of x and plug it in everywhere you see an x in g of x. So I'm going to have 1 over x squared minus 2 times x squared. So everywhere there is an x in g of x, you plug in x squared. And again, you can leave it in this form. And then from there, it wants you to find f of g of 4. Well, we found f of g of x, so we can just plug in 4 in for x. Now just be careful here. Follow your order of operations. So you've got 1/4 minus 8, and that's all squared. We need to get a common denominator to subtract 1/4 minus 8. So think of this as over 1. I have to get the common denominator of 4, so I'm going to multiply top and bottom by 4. So that will give us 1/4 minus 32 over 4. And then that is still squared. So now that I have a common denominator, I can subtract. 1 minus 32 is negative 31, and the denominator stays the same. And then you have to square that. If you square negative 31, careful if you put it in your calculator, you've got to put parentheses around the negative 31, because you should get back a positive 961 over 16. If you don't put parentheses around it, it's going to give you a negative back, and a negative times a negative, when you square it, gives you a positive. So now let's look at g of f of 4. We're going to plug that in. So we'll have 1 over 4 squared minus 2 times 4 squared. Again, be careful with your order of operations. This will be 1 over 16. But on this next one, you need to square the 4 first, because the exponent comes before multiplication. So you'll have 2 times 16, which will be 32. And then again, you need to get a common denominator. So I'm going to have to multiply this top and bottom by 16 to get my common denominator, which will be 1 minus 16 minus 32 times 16 is 512, and then over 16. So once we have it all over 16, you can just subtract the top. So 1 minus 512 is negative 511. So That's how you get f of g of 4 and g of f of 4.